Hello and welcome everybody to another edition of our GoToWebinar presentation for Sub-Saharan Africa. So today we shall be discussing the Fronius GEN24 Plus installation and commissioning. And the presentation team today is myself, Cyprian Okolo, the Technical Sales Advisor for Western Africa, and then my colleague, Mohamed Sidat, who is with the Fronius South Africa, and which is a subsidiary of Fronius International. So together we shall be presenting this interesting topic to you today. And going further, the agenda for today, we have it here, as you can see. So just going through it, we shall be handling the professional installation of the Fronius GEN24. We shall now go through the cabling, data communication, initial commissioning, Fronius GEN24 compatibilities, and then we'll now go through maintenance and servicing. Then afterwards, if time permits, we shall take one or two questions and then answer them from the chat. Great. So let's now continue. And we now start, as earlier advertised, with the professional installation of the Fronius GEN24. But before we do that, we'll have to give you an overview of the inverters in question. So these unique inverters come in two variants, that is the three-phase and the single-phase. For the three-phase, fondly called the Symo, as we maintained the generic name. So this hybrid inverter, like I said, is three-phase, has two MPPT inputs of 25 amps and 12.5 respectively, and then ranges in power class from 6 to 10 kilowatts, and of course has a battery input, meaning that since it's a hybrid inverter, it of course implies that it has battery connection compatibility. Yes, ability. So the battery input is 22 amps current carrying capacity. And then talking about the single-phase hybrid inverter, which is fondly called the Fronius Primo GEN24 Plus. Of course, it's single-phase, has two MPP inputs like the Symo, this time 22 and 12 amps respectively. And of course, comes in power classes ranging from 3 to 6 kilowatts. And of course, as the Symo also has one battery input with 22 amps current capacity. The Primo is scheduled to be rolled out at about Q2 2021. It's 2021. Yes, so we'll have that corrected. So what do we need for a proper installation? So basically you need the basic installation tool you need is a screwdriver, preferably a Tox 20, because we're going to be carrying out 180 quick locking and unlocking mechanism. And then of course a manual, which is commonly called the quick start guide, is always available in the product pack. And then of course a monitoring device via SolarWEB. So for installation instructions, both for the Primo and the Symo, this is a very unique and rugged device that can be installed both indoors and outdoors. It has an ambient temperature range of from -40 to +60 degrees centigrade, -40 for the Primo, and then -25 for the Symo in the lower temperature range, and then of course 60 degrees in the high temperature range. Of course, it has a 0 to 100 permitted humidity. And another unique thing about it is that in terms of altitude, it can be installed up to 4,000 meters above sea level. That's for the Primo. And then 3,000 meters above sea level for the Symo, maximum installation altitude. But for the VDC, it has unrestricted it's unrestricted for in terms of altitude above sea level for the VDC. And installing it in sites, there are some basic directives that's to be followed. So for both single phase and three phase, that is for both Symos and Primos. We should always make sure that it's installed under a shade. Of course, it's an outdoor device, meaning that it can be installed outdoors, but we should try as much as possible to install them under a shade. In most cases, or preferably under the PV generator shade. And like we said earlier, or like I said earlier, it can be installed up to 4,000 meters above sea level. That's for the Primo. So this is the maximum level that should not be exceeded. And then in terms of closed environmental factors, like earlier said, it should be installed under a shade so that if it comes under direct sunlight, it can of course increase the ambient temperature and might lead to derating. In addition, because of let's say the fan noise, it's not advised to install in the living room or in a farmyard or close to where animals are being shedded. This is because of the cow or animal dungs tend to contain toxic materials, usually ammonia, and this is, since they're toxic, not too good to come in contact with the inverter. Dusty areas should be avoided. Of course, enclosed areas such as the greenhouses should also, we should not have this inverter installed because of the increased ambient temperature that is likely to happen in greenhouses, for example. So like earlier said, in industries close to areas where they can be exposed to toxic materials should be avoided. Yeah, so in terms of inverter mounting orientation, so the conventional mounting rule applies. So either vertical or horizontal or inclined upward surface is admissible, but then any other orientation apart from this should be avoided. In terms of clearance, about 200, or to be exact, 193 millimeters should be observed from the top. 225 millimeters clearance should be observed from the sidewall. And then if you're installing more than one side by side, a minimum distance of 170 millimeters should be observed. And then the downward space, downward clearance should be at least 300 millimeters. That is for the Symo GEN24 Plus. And then for the Primo, top clearance should be 193. Sideways to the sidewall is a 225, same as the Symo. And then the same thing applies for other clearances, both side by side and then bottom clearance. So yeah, one thing that makes this inverter stand out is its maximum yield because of its active cooling technology. This we implemented in conventional snap inverters, and because of the success recorded, we implemented the same thing. Although in this case, the propagation of air is different because in this case we have a central fan or a central cooling fan that tends to draw in cold air and then emit hot air around the inverter, as can be seen illustrated here. So a direct suction of ambient air is carried out or implemented from this, on the front of the radiator, and then this, of course, implies the consistent removal of heat across or along the side of the inverter. Okay, so wall mount, wall bracket, and wall mounting. So in this case, certain directives has to be observed. So in terms of a correct selection of fixing materials, let's say in this case for a fissure, the diameter pre-drilling for fissures are usually 6 to 8 millimeters. And once this is done, it should be easy to install. But one thing we have to note here, even with the fact that uneven surfaces are usually compensated because of the already pre-designed grooves on the wall mount bracket, we should try as much as possible to avoid deformation due to manhandling of the wall mount bracket. So as you can see, you already have direction arrows onto where you can mount your wall mount bracket. So while mounting, we have to make sure that it is well in place. And by the time you want to hang in or snap in the inverter, you usually hear a click sound, and this can also be observed visually from the alignment of the round holes or clicking grooves, as can be seen or illustrated here. So if it is not perfectly aligned, please make sure that it is, because it might be impeded due to maybe an obstruction or so. So we should make sure that it aligns properly, and in order to ensure that this happens perfectly as it is supposed to, you're going to hear an audible click. And then, of course, with the visual inspection, you can be double sure that the inverter is properly installed. So we should now go through the cabling of the Fronius GEN24. The one unique feature about this inverter is the 180 degrees quick locking screws. So for this, all you need is a Tox 20 screwdriver, and in order to implement, or in order to perform locking and unlocking processes, you don't need to turn and turn clockwise or anti-clockwise as we usually do for conventional screws. So what we have here installed are 180 degrees quick locking screws. That means you just have to turn to the left or right, depending on what you want to do, whether locking or unlocking. So because of this, no cordless screwdrivers are allowed, because if you do so, of course, you might end up damaging the screws and the thread. So as we can see on the inverter cover, we have 2 of these screws, and then on the datacom cover, we have 5 of them. So we're going to see this in display and in action in video I'm going to place in the subsequent slide. Yes, so by the time you unscrew or unlock the datacom cover, you will now have access to the cable connection point. So here you would see the DC connection point, the AC connection point, and of course, the pilot or the data communication area. So I guess I have listed them all, so we could just start over again. So we have the DC connection point where you connect your PV, your modules to. So you have the plus region and then the minus region. And this, of course, also contains the battery connection points, that is the positive and the negative battery connection terminals. This is now followed closely in between the DC and AC is the pilot. We call it pilot, which now replaces the name that we normally call the data communication device for the conventional snap inverter. As we know, we usually call them data manager, but in this case, we call our data communication card the pilot. So we have this separation area for protection, and then afterwards, we now have a grounding terminal block just after the protection or the separation. And then afterwards, we have the PV point and then the AC clamp or the AC termination point. The PV point is a special connection point where you can actually use to get power directly, even without battery connection. And I'm sure we're going to discuss about this in the subsequent slides. So operating elements and connections. So as I earlier said, we have the grounding connection point. So this is done in order to ensure proper grounding. And we have the materials here, the fixing with the screwdriver, usually Tox 20, and the force to be applied is usually between 1.8 to 2 Newton meters. And then, of course, for the functional grounding on the top of the clamp, it is usually dimensioned at 10 mm squared. So for the AC and DC cable glands, as you can see them indicated, they're usually, it comes in the form of a strain relief. which is usually an M32. And then the force required is 6 to 7 Newton meter. And we should always mind the grounding when doing this. That is for the AC side because of its the closeness with the grounding cables. And then on the DC side, the cables are usually fed through manually because there are straight cable connecting points that lead directly to the bagel clamps or the DC connection points. So you don't need to use any sharp tools or knives to perforate these areas. They are easily connectable and fed through. Okay, so cable glands for the data communication, this can also be seen. It passes through the cable glands, which usually comes in a strain relief form. And then all we need to do is to slot in the communication cable from the slit provided. And we should always make sure that unused slots remain covered. So as to prevent any unwanted particles from entering into the inverter. So how about DC options for Fronius GEN24 series? So we have DC protection device, which is usually called DC SPD. SPD simply stands for surge protection device. So we have the type 1 plus 2M multi-string. And it's usually a retrofit kit, and it's of course it's not available ex factory. So all you need to do is to order it from your wholesaler, and it comes with the printed circuit board, 4 screws, Tox 20, grounding cable, 2-pole signaling cable, and of course your positive and negative PV cables. So as you can see them here. Well described. So this is the print circuit board that comes with the inscription of your connection point. There's a positive and negative connection points. So your PV goes directly to the connection point via the bagel clamps, and then you can now connect your PV generator to the respective terminal points provided. So, and then one question that usually pops up is it possible to configure one string with 3 modules? So in this case, for this inverter, we added to its design a Superflex design, which makes it possible for it to have a string with as low as 3 modules. So all that is needed to be done is to reach the threshold voltage of 150 volts, which is quite low in terms of DC threshold voltage. So it makes the inverter quite unique for this purpose. So this condition that needs to be satisfied in this case is that at least one of the MPP tracker exceeds 150 volts, which is the minimum threshold voltage. So once this is done on one MPP tracker, the other MPP tracker picks up. So for example, for a Symo GEN24 Plus with an asymmetric configuration, if you have on tracker A 6 modules, of course this exceeds 150 volts, it picks up and starts operating, and then drags, you could use that word, also activates the other MPP tracker to operate even with lower modules. So that is what is meant with this Superflex design. So connection of inverter to wall bracket. So we've handled this before, but just to add, all you need to do is to mount the DATCOM cover, use the 5 180 quick lock screws to hold it down, snap in the inverter, mount the cover that has just 2 quick locking screws, screw them down. Always note that no cordless screwdrivers are around so as to avoid damage, and then switch on the circuit breaker, and of course the DC connector should now be put on the on position, and then you have your connection already done. So for the integrated safety devices that we have for this inverter include insulation measurement, which is also active at night even before the DC is on, the residual current monitoring unit, commonly called the RCMU, that helps in monitoring feeding process for any differential current, Anti-islanding also is available in order to identify power failure and quickly shut down or instantly shut down. We also have reverse voltage protection via diode in order to protect device from short circuit. And as earlier said in the previous slide, a surge protection device that which is optional and can be integrated on the DIN rail. And then of course, output power reduction. And this is actually done via frequency shift mode in order to avoid overload and high temperature. So, like I said, I was going to see if I can play us a video to actually describe everything that I have been saying so far. So, as you can see, this is just a short video about the process of installation. So, as earlier said, installation of the wall mount bracket. Then after that, you now snap in the inverter. So in this case, like I said, as you can see, the groove, the circular groove indicated here. So you can not just hear the click, you can also observe it to be sure that the inverter is firmly in place. Then afterwards, we can now screw down the 5 180 fast lock screws. Just all you need to do is just to turn it, unscrew it 180 degrees. Then you can now have access to the connection area, connect the DC cables, and always ensure that the inverter is voltage free while doing your connection. So you can remove the bagel clamps and then slot in your DC cables. It's that easy. So no need for screwing. All you need to do is to push in and then press down the push in springs, and then your cable is now held in place. As you can see, it's being done here practically. Slot it in and then push in the spring clamps, and then your cable is held firmly in place. Next thing to do is to connect the AC cables. So for the Primo, you will need just 3 cables: the live, your neutral, and your ground. And for the Symo, you're going to need 4 cables. Yeah, so the 3 phases, and then yeah, the 3 phases L1, L2, and L3, and the neutral, and of course your ground. So for the Primo, you just need 3 cables: live, neutral, and then your ground. Okay, let's continue. So afterwards, you now cover, slot in the DATCOM cover, and then screw the 180 locking screws. Afterwards, you now screw in the 2 locks for the inverter cover. After that, you switch on the inverter, and then your inverter, the installation is done, and your inverter is ready for commissioning. So that's it about the installation. So the next section we'll be going to is the data communication of the Fronius GEN24. Well, like I told you earlier, the pilot is what we use for the data communication for GEN24 Plus inverters. So upon connection, the installation, this makes the pilot active, and then via the router, you can be able to visualize whatever or the activity of your inverter via a SolarWeb. And then this can be done, of course, on web-enabled devices like your PCs, your tablets, your phone, smartphones, and even smart watches. Okay, so we're now going to look at the pilot in more detailed format. So the pilot basically consists of LED display status, the data logger, the web server, the Wi-Fi card, the visualization via Fronius SolarWEB is done there, and then of course via Fronius SolarWEB app, and of course Solar TV. So with the pilot, you can actually actualize all these features. So as we can see here, we have several features which we shall be treating one after the other. In terms of multiple open interfaces, yes, it does have multiple open interfaces. It has two Ethernet or LAN ports, which is used for Modbus TCP or Fronius Solar API or JSON protocol. It has two Modbus RTU interfaces, and then a wireless shutdown function, and then digital input and output ports. So we shall be looking into them subsequently. Yeah, so as you can see here, we have an overview of the integrated interfaces as mentioned earlier. So for the Modbus, we have, as earlier said, two Modbus interfaces. So we have them labeled MO, that is Modbus 0, and Modbus 1, each having a 12 volts and ground terminal. So these are usually used to connect Fronius smart meter, home pilot, solar battery, and sunspec interface. So for both switches, for them to be activated, it has to be put on the on position or on the position 1. As you can see here closely, this circle or this region here and squared is consists of two switches, one for Modbus 0 and then one for Modbus 1. So depending on the Modbus you want to activate, all you need to do is to put the switch on position 1. Then if you want to deactivate it, you put it on position 0, because this position actually connects to the termination resistance. So if you put it on, that means you are activating the termination resistance, and you can now use that particular Modbus interface. If not, you put it on the 0 position, thereby deactivating the terminal resistance. So as can be seen here, in a more detailed fashion, we have the supply voltage, the MO plus and the MO negative here below, and then we have the shield, then we have the M1 plus and M1 negative, and then of course the power supply, V plus and then ground. So all described and all described in the boxes here as can be seen. So the D plus and D minus represents the MO and M1 respectively. So for the overview of, still on the overview of integrated interfaces, the wired shutdown function is actually a function that is used to implement an emergency shutdown of devices in the case of, let's say, an incident like a fire outbreak. So instead of looking for how you can start to disengage the device in case you don't have access to the house in case of a fire outbreak, like I said, this can actually be connected to an emergency button placed usually at the entrance of the house, so that once there is need for this emergency, you can just push the button and the whole devices will be shut down immediately without you necessarily having access directly to these devices. So it's actually a connection that comes in very, very handy in such events. So also we should mind here that the maximum distance between, that is if there are more than one device, the maximum distances should be 100 meters, and then it can be done for a maximum amount of 10 devices. Yeah, so this function actually comes in breached X factory. So if we want to carry out the connection, it now has to be done properly from the in to the out port. So we now talk about the digital input and output ports. As we can see here described, we have 6 input and output ports, that is input output 0 to input output 5. And then we also have 6 digital input ports, that is from input output 6 to input, digital input 6 to digital input 11. So this gives us a whole wide range of options to pick from, and these ports are actually used for intelligent load management of pool pump, air conditioners, charging stations for EV, heat pumps, and the likes. Also can be implemented for backup power and demand response mode. Yeah, so in terms of the LAN, we have 2 LAN ports, or Ethernet ports, as it's fondly called. We have one USB slot. Now, we should take note that this USB slot, in comparison to what the USB slot can be used for the conventional snap inverters, we know that we can use the USB slot in the conventional snap inverters for remote updates, but in this case, the USB slot is for power supply only. It is for power supply only, yes. And then LED status display will be discussed subsequently in the coming slides. Yeah, so Wi-Fi access point. So how do we open a Wi-Fi access point? It's quite simple. All we need to do is once to ensure that the inverter cabling is done, we mount the DATCOM cover and the inverter cover. The DC connector is placed on the on position, and then tapping on the light sensory button in between the LED indicators, you you have successfully opened the Wi-Fi access point, and this will be shown by the blinking of the blue LED indicator. And for more on this, my colleague Mohammed Sidat will continue from here to give you more information on from the subsequent slide he will be presenting. So Mo, I will be handing over presenter rights to you so that you can continue from this point.
Thank you, Cyprian, for the very good first session. I will now take you through the initial commissioning of the Fronius GEN24 Plus inverter series. How does the inverter communicate? So previously with the Snap Inverter series, we did have a screen at the bottom left of the inverter. We have now, with our new generation of inverters, we have removed the screen, and as my colleague Cyprian told you, we now have a touch-sensitive input interface. So if you look at the top right of the screen, you can see that we have this little touch-sensitive input, and we have 2 LEDs on either side. Okay, the LED can basically toggle between green, orange, or even red, and also blue as well. So it could basically indicate different states to you. So let's say if we do want to open up the access point, all we do need to do is we need to tap the button once, okay, and this will now activate the access point, so we can now commission the inverter. If we push the access point twice, we can now activate the WPS function. And if you do one long push, which lasts anywhere between 3 to 6 seconds, we can basically quit any service messages, and we can also do a D or an activation of key lock. Okay, so key lock is basically a system which will prevent anybody from clicking on this button and maybe doing some changes. How to do the commissioning of the GEN24? There's 2 ways you can do it. You can download the smartphone app, which is called Fronius Solar.start. This is available on both the iOS and Android app stores. And this again is available for smartphones and tablets. Okay, with the smartphone app, it makes the commissioning process a bit more streamlined and a bit quicker. Okay, but again, we do get installers who do prefer to use the web browser to commission a Fronius inverter. This will still be possible. Again, when you do use a web browser, please make sure that you switch on the Wi-Fi access points of the GEN24. What you then need to do is open up a web browser. We recommend that you do use Google Chrome. Once you've opened up the browser, you then need to enter the IP address. So this IP address is basically the same IP address of the access point of the Fronius Snap Inverter series. Initial commissioning of the pilot. So what do we need to do first when we start commissioning? Well, we have to open up the access points of the inverter. We do this by clicking on the button once. Okay. Once you do this, you then go to your laptop. As an example, you then search for Fronius_pilot. Okay. And then it will have some digits next to it. Those digits are basically the serial number of the pilot. Okay. Once you've done that, it'll ask you for a password. The password is always 1, 2, 3, 4, 5, 6, 7, 8. Okay, you enter that. You then open up Google Chrome. You then enter in the following IP address. Okay, once you enter that IP address into your web browser, the commissioning process will now begin, and you will now be brought up with an installation wizard. Okay, so this is basically a screenshot of how the installation wizard will look. And once you've done the commissioning, you'll basically finish up in SolarWeb. So again, please make sure that you do have a network connection already established on site. With the installation via the via browser, this is basically what we call now a LAN or Ethernet connection. Okay, so previously we were looking at using the Wi-Fi access point as a connection medium. Now we're going to look at using a LAN or Ethernet connection as the medium in which to commission a Fronius GEN24 inverter. Okay, firstly, we need to take your laptop to site, connect it directly to the LAN port on the pilot using a Cat5 cable. Okay, you can use Cat6 if you want. Again, if you are going to use this method, no need to enter any password. Okay, all you now have to do is enter the following IP address in the address bar. Okay, so this IP address is different when you use the Wi-Fi access point. Once you've done that, please open up the installation wizard in your web browser. And again, please make sure that you do have a network already established on site so that you can do the finishing in SolarWeb. Where to assign which passwords? So with the Gen24, we have different levels, which basically has different passwords. Okay, so whenever you commission a Gen24, you will sort of have different profiles, let's call it that. So for example, if you assign a customer password, okay, you can basically do some network configuration. With a technician password, you can basically do some product configuration. And in terms of your normal SolarWeb platform, this again is done through our solarweb.com web. A very nice feature is that you can send an invitation by email from an installer to a SolarWeb end customer. So you can basically invite your end customer to SolarWeb. Which passwords are assigned? So with the guest, no login data needed. Okay, so you can basically log in as a guest and not enter any password. Assignment is possible anytime. No possibility to do commissioning of inverter or to do any changes to the network. You can only observe what's happening in the system. And all menus, sub-menus are locked. Okay. Then the second profile we do get is the customer profile. For this profile, we do need to assign a password. Okay, so if you are an installer and if you are going to do an installation for your customer, please make sure that you do set up this customer profile for him. And please make sure that you also provide the password for this account as well to your client. Customer access is needed for network settings. Again, if the customer ever wants to change his network to which the inverter is connected to, he should again be able to do this himself. However, there's no access to critical network parameters. The third profile is the technician profile. For this profile, you do need to assign a password. Okay, so this is a profile in which the installer will create for himself. Technician access is needed for product settings, okay? And with the technician profile, you basically have unrestricted access to inverter settings. The only exception you do not have access to is the grid code settings. Again, if you do want to get access to the grid code settings, you can request it from Fronius tech support. Okay, I just want to point out something else. If you do go to the web user interface of the Gen24, you can see that we basically have these little locks. Okay, so if you log in as a guest, you cannot access those profiles. If you log on as a customer, you can basically access everything besides the power grid settings. Okay. Technician, you can pretty much access everything besides your grid code settings. How does the web interface look like? So this is basically a screenshot of the landing page of the web user interface. You are kind of greeted with the energy flow of the Gen24 immediately. And yeah, you just get your basic data from here. Again, you can get much more in-depth analysis through SolarWeb. Moving on, we now will discuss the Fronius Gen24 Plus compatibilities. Firstly, we'll discuss thermal storage solutions. So from Fronius, we do produce a product called the Fronius OnPilot, which is basically a stepless PV surplus energy control device. And this basically allows you to connect, for example, a purely resistive load to it, and it allows for stepless control of that resistive load. Okay, so using such a device, we can aim for maximum self-consumption. We also have the compatibility to attach battery storage to the Gen24 Plus inverter. In terms of the batteries that we can use, it will be the BYD Battery Box Premium HVS/HVM. This is a lithium iron phosphate battery technology. Again, it's extremely easy to commission it. It comes in a very modular design. So for example, in this tower, we have 4 blocks of batteries, and the top black box is your BMS, which is your battery management system. Each block of battery is plus minus 2.5 kilowatt hours, and the minimum amount of blocks you do need is 2. So using the Gen24, you can pretty much start with a minimum storage of 5.12 kilowatt hours. Okay, so if you do go for the minimum storage, it will just be the base, the first block, second block, lastly with the BMS, which will then be your top block. Okay, using such an approach, it's again very easy to increase your storage going into the future as well. We also have the ability to provide emergency power without the need of a battery, okay, as long as you are producing PV power in the day. Okay, this is through the PV point, which is integrated in our entire Gen24 Plus inverter range. So the PV points on board, it provides basic backup power function. It's integrated as standard. No additional installation is required. No battery needed. And you can basically have a backup supply of 3 kilowatts single phase. Remember, this PV point will not be active at night. It will only be active when you have power coming from your DC panels. Looking at the PV point in more detail, the PV point is a free basic backup power function on board. Okay, it's integrated as standard. It can provide an output of up to 3 kilowatts single phase. However, it can provide an output of 4.1 kilowatts for 5 seconds. Okay, this is very useful. For example, if you are going to connect your fridge or whatever to this PV point, and for example, in the fridge, you do have a motor which maybe for the first 4 or 5 seconds will draw a slightly higher current than what its actual nominal current is. Okay. This will be supplied in the case of a grid outage. So let's say the grid goes down. Our inverter will also go down with the grid. However, it will only go down for less than 20 seconds. Okay, during those 20 seconds, it will create its own reference and then come back online. Okay, so basically our inverter can operate when the grid is down. The nice thing about the PV point, it has its own dedicated exit from the inverter. So basically, you do not need to install an additional grid separation box if you're going to use a PV point, which again can save the end customer a lot of money when he's looking for basic backup functionalities. As I alluded to earlier on, this provides functionality without a battery. And again, if you do want to add a battery in the future, it is possible. So looking at the PV points, as I said earlier on, the PV point is only active as long as you have enough PV generation from your modules and as long as the grid is down. That's when the PV point will now activate. Okay, you can also, have the option to add a battery into the system. So yeah, as shown in the picture. And using your battery, you can also provide that basic backup on your PV points. Again, this is very interesting, and it's actually a very good use case for an end client. So now you can also get that basic backup from the PV point just through using your battery storage. How to install the PV points? So if you look in this picture over here on the right, we have your neutral, okay, and your L1, and then we also have your grounding block over there. So you can pretty much see how this is actually grounded to our grounding block, which is inside the inverter, and then your neutral and your line basically then goes to your plug points. Okay. However, before your plug point, we do recommend that you install an RCD, which is basically a residual current device. And basically the feature of an RCD is basically to spot any differences in between your line and your neutral. And again, if there is any difference, the RCD will trip, and this will prevent you from any electrical shock. Okay, we do recommend a specific RCD, but again, you can install any RCD on the market that has the specific current output ratings of the PV points. Again, the example of the PV point is now you do not need an additional grid separation box, which again costs way more than just purchasing a single RCD. Okay, just to show you a single line diagram of the correct cabling of the PV points. So over here we have your Fronius Primo GEN24 Plus inverter. Okay, we then have your backup loads over here, and this now is your PV point. So you can see your neutral is grounded, okay, and this ground is basically the grounding block inside the Gen24 inverter. Okay, your line and your neutral then basically goes to the RCD, okay, which again will detect any differences between these two lines. From the RCD, it then goes to a dedicated plug point where you will then have your dedicated backup loads. Remember, the PV point is only active when there is a grid outage. Now to move on to further open interfaces. So with the Gen24, the communication is standardized on board. So we can allow communication with third-party components. And again, this fits really well into the fields of e-mobility and into energy management as well. In terms of the interfaces on the pilots, you basically have your LAN, wireless LAN, Modbus TCP SunSpec, your digital input and outputs, which is really useful to trigger an external relay, and also your Fronius Solar API, which is your JSON communication protocol. Now moving on to the next important section of the Gen24 Plus, which will be the maintenance and servicing of a Fronius Gen24 Plus. So in terms of the LEDs in the front of the Gen24 Plus, they can also kind of indicate many different things. So for example, I have a table on the right, and if, for example, my power, which is that LED over there, is flashing, and my communication LED is yellow, it means that the inverter is starting up. Okay, so it's nothing you should stress about. However, if we look at this one over here, so if our power button is now red, and if our communication is now blue, this means we have a critical error, okay, which could affect maybe the power board. However, we do know that the network is still connected, so the error is not with the network. However, if you look at the next scenario, the power is green, which means that the inverter is running fine, there's no issues. However, the communication is red, which now tells us that maybe the communication between the Gen24 and the local router is broken. Okay, again, you can have a look at all these different LEDs, what they mean, and we will be sending this presentation out to you as well. How to read out errors without a display? That is a very good question. As you know, with the previous snap inverter series, it did give you the error code on the screen. However, now we've gotten rid of the screen, and now you have to see how to get this error code without a display. So basically, you have to look at the LED status of the inverter. Okay, so this is shown on the right. The error message or state code appears in Fronius SOLAR.WEB and the inverter dashboard. Okay, so the inverter dashboard is the web user interface of the inverter. The state code will be a 4-digit code. Okay. However, with the Gen24, we now no longer have state code groups, such as with the Fronius Snap Inverter series. Your state codes will always be created in ascending order. In order to distinguish what a code means, we can use our Fronius SOS tool, which is a free-to-use tool for Fronius installers. And using the state code tool, we can basically sort of determine and distinguish what exactly is causing this error. How do you do an update on the Gen24 inverter? So you can do a remote update without an appointment and trip to a customer's site. Remember, as my colleague Cyprian said earlier on, we can no longer do USB updates with the Gen24. You will now be forced to do a remote update on SOLAR.WEB. Okay, with SOLAR.WEB, all you have to do is you need to go to Settings, Components, and then you have to click on Update. Okay, please do remember that sometimes you might need to activate the pilot card, and sometimes you might also need to activate the firmware of the Gen24. So in terms of the service concept of the Fronius Gen24 Plus series, again, we will be aiming for the fastest service on the market. So with the Snap Inverter series, as you do know, if a board goes, we can replace that board very quickly. Same thing with the Gen24, we will try and ensure that we can get the fastest service possible to installers. Okay, so exchange of components is possible. You will get an automatic notification. Your problem solution can be done by SOLAR.WEB. This will then lead to one trip to site. So you don't have to go multiple times to site to do a service. We can just go to one trip and that's it. Okay, easy access to connection unit for the installer. So you don't need any special tools to remove the power stack. And again, with a fast solution, we can make sure that our customers always remain satisfied. Which spare parts are available? So again, you can replace the whole inverter. You can replace the power unit. So the power unit basically contains the DC board, the filter board, and the AC board of the inverter. So pretty much all the power electronics in the inverter is in this power unit. You can also replace the pilot, which is the communication card. You can also replace the cover of the Gen24. So that's your front cover and your DATCOM cover. And again, you can also replace the fan. Okay, so remember with the Gen24, we now only have one fan, which is right over there. How does Fronius service process work? Okay, so you'll get the end customer who will be sitting with a Gen24. With them, all of a sudden they have an issue, they will call the installer. Installer can then go on SOLAR.WEB to have a look at what the issue is. Once he gets an error code, he can basically use the SOS tool to check what that error code means. If he can fix this himself, he can go ahead and do it. If he needs further assistance, he can then contact our Fronius Tech Support Hotline. We will then guide him with a step-by-step process in order to sort this issue. Again, let's say if, for example, he needs to exchange the entire inverter, we can provide him with a new inverter. The installer then goes to site and then exchanges the inverter for the client. Okay, please remember in Sub-Saharan Africa, we do have a lot of export markets. We do also have an agency as well in South Africa. So with our local presence in Africa, we can really provide a fast solution to any issues that the customer could have. Okay, looking at the exchange of the power units of the Fronius Gen24 Plus inverter. Okay, so in order to exchange the power unit, you have to remove the front cover of the Gen24. You then have to remove the DATCOM cover. And once you've done that, you then have to remove the pilot, which is the communication card. Once you've done that, you then need to remove your WEGO clamps, okay, which is those orange clamps over there. Once you've done that, you then need to remove the separation unit, which separates your DC, AC, and your comms. Once you've done that, please then remove the grounding terminal in the inverter. Once you've removed all of that, you can now pull out the power stack, and you'll now be left with the back cover in your front cover and your accessories. You then return the power stack to Fronius. So when it comes to returning it to Fronius, we work through our distributors in Sub-Saharan Africa. So you basically give it back to the distributor. The distributor will then give you a new power stack. You then go back to site and now fit in this new power stack. Okay, please make sure that you do the licensing of this new power stack as well. Okay, so that's the content for today. Already the time is up already, but again, if you have any further technical questions, please contact one of those numbers on the screen. And again, I would please advise you to please contact the appropriate number for the appropriate service that you do need. Again, you can also contact one of your technical sales advisors in Sub-Saharan Africa. But yeah, thank you again for attending today's webinar. And yeah, until next week, Friday, I'd like to say goodbye from my side. And I'd like to hand over to Cyprian for the closing remarks. Cyprian?
Yes, thanks a lot, Mo, for a wonderful presentation. Most of the questions here are actually pointing towards our next topic of our next presentation topic, which is the benefits of a lithium HV lithium ion batteries. So we will be looking into that because I've been asked if we can use alternative batteries other than the BYD. So we're going to make a case for the benefits of actually using lithium, because inverter can, for now, is compatible only with the HVM and HVS BYD premium battery boxes. So stay tuned. Next week, we shall be treating this topic in more detail. So other than that, I want to thank you all for attending. It was indeed a pleasure having you around, and see you next week.